then somebody's throwing in a bottle of petrol stuff.
And what age is old enough to have sex in Kenya? 2 tankers have been damaged in suspected attacks in the Gulf of Oman, one of the world's main oil export routes. Television pictures show flames and billowing smoke. It's an incident that could inflame tensions in this politically sensitive region. Our defence and diplomatic correspondent, Jonathan Marcus, told me more.
One of them certainly looks as though it's well on fire with an explosion towards the middle of the vessel. Well, what we know is that these 2 ships both suffered explosions. Both vessels, the crews were able to get off the vessels. Certainly, some were picked up by others were picked up by a US-guided missile destroyer, the USS Bainbridge, which was diverted to the area. This is a very serious episode because it comes against the backdrop of mounting tension between US and Iran. Attacks a month or so ago against 4 oil tankers using limpet mines, which the Saudis and the Americans ascribe to the Iranians. The Iranians, of course, deny that, but the Americans have sent additional air and naval forces into the region, and so with tensions running high already, these 2 latest attacks, we don't know their origin yet, but they inevitably stoke up the pressure significantly.
And this is the second attack, if it is an attack, or the second incident of a similar kind in a matter of weeks, isn't it?
Well, indeed. I was referring to those attacks a moment ago. A month or so ago, attacks off the UAE. There, the tankers were attacked with limpet mines physically attached to the vessels, presumably by frogmen. Those vessels, I think, were anchored. It looks as though the 2 ships attacked today were actually underway. They were moving. So presumably, if it was an attack, then the means of attacking them would have been rather different. Now, having said that the Americans have significant naval assets in the region, one imagines that they will be monitoring movements in the area very, very closely at some point in the not too distant future. If they feel confident that they can say who or what attacked these vessels, one imagines they will say so. But as I say, it is a hugely difficult situation right now. And of course the worry is not so much that Iran and the United States are heading on a path to a deliberate conflict. The worry is that episodes like this, whoever did it, misunderstood, misjudged, miscalculations, could lead to somebody doing something that will push the envelope just that too far and will lead to some significant military response.
Briefly, Jonathan, have we heard anything from Iran yet?
Well, the Iranians, of course, insisted that they've been acting in a humanitarian way, picking up the crews, and certainly the crew in one case. They say that one of the vessels has actually sunk, though that doesn't necessarily appear to be the case. Oil prices inevitably rise, and there will be very real concerns for the safety of shipping in this crucial waterway that carries so much of the world trade in oil.
Jonathan Marcus. The authorities in Uganda have put the country's health system on full alert after 2 people died from Ebola. Both victims travelled from the neighbouring Democratic Republic of Congo, where almost 1,400 people have died from the disease. Widespread violence and political unrest in the DRC has seen 300,000 refugees flee to Uganda. The BBC's Dear Jian is in Kampala and told me how the authorities were preparing to deal with the outbreak.
The authorities have actually taken it very seriously. Since the first day that the first case was confirmed, the Minister for Health and a number of officials have camped in the area where the cases have been confirmed in. And they have been meeting different people. They have met religious leaders. They have met with the traditional leaders, trying to ask them to solicit for their support in campaigning, in telling people what they should do. But also they have been doing radio shows, talking to the people, and even they have met with the people themselves to try and talk to them on what they should do so that this crisis does not hit them.
So lots of campaigning going on. Does the country have the infrastructure to cope with a potential outbreak?
As it is right now, the infrastructure is available. But if the situation gets out of hand or reaches the status that it is like in DRC, then it could get worse and it would be unable for the current existing infrastructures to handle the.
Space, they transformed our ideas of what the Earth was like. It was every bit as beautiful and awe-inspiring as we had imagined. But there was something else very striking, how utterly alone this fragile blue sphere was. Here was a rich, vibrant, living world, surrounded by infinite empty darkness, an image that gave a tremendous boost to the growing environmentalist movement. Looking after the planet suddenly seemed to be so much more important. If we ruined our own Earth, there was nowhere else to go. Since then, barely a week has gone by without global environmental issues hitting the headlines. Desertification, pollution, extinction, and a host of other threats are said to be endangering life on Earth. But just how real are all these problems? What effect will they have on our lives? And can we do anything now to make sure that our grandchildren inherit an Earth that is, well, worth inheriting? I'll be trying to answer some of these questions in this series. We begin with climate change. You might also have heard it called global warming, though scientists disagree on whether a warmer Earth will be the final result. It's one of the few global environmental problems that has led to a worldwide treaty, but it's also provoked bitter political debate. Some world leaders argue that the problem is not serious, or even that it doesn't exist. Funnily enough, these are often the leaders whose countries are accused of being largely responsible for the problem.
Considering the United States, with 4% of the world's population, produces 24% of its carbon dioxide, the United States is unquestionably the villain of the piece at the moment. The other industrial countries are all, in different ways, trying to limit their emissions of greenhouse gases.
Crispin Tickell, a former British diplomat who is an expert in the politics of climate change. It is, he claims, one of the most urgent and far-reaching crises facing the planet. He is supported by scientists from across the globe.
We're locked into climate change at this point for a little bit of time. Even if we were to lower releases of greenhouse gases today, it would be several decades before we started seeing the response of that.
The problems with climate change are a creation of the industrialized world, and the consequences are felt the most in the developing world. The fact, however, is that if climate changes, even the industrialized world is going to be hurt. It may not feel hurt today, it may be tomorrow, but tomorrow is also close. We're all the losers in the long run.
If we continue to pump carbon dioxide and other greenhouse gases into the atmosphere, we can expect a temperature rise across the planet of something like 3, 4 or 5 degrees over that period.
We've also seen different parts of the world get wetter, other parts get drier. We've seen more extreme weather events such as heat waves, heavy precipitation, and we've also seen sea level rise 10 to 25 centimetres, and most of the glaciers throughout the world also receding, in other words melting. So there seems to be very good observational evidence that the Earth's climate is indeed changing.
This chorus of alarm has been reflected in the media coverage of the issue, which predicts a gloomy future for the Earth if nothing is done. Why is our climate changing? Lara Hansen is a scientist at the Worldwide Fund for Nature. The root cause of the problem, she says, is what are known as greenhouse gases. The most abundant of these is carbon dioxide, produced when fossil fuels like coal and oil are burnt.
Greenhouse gases, which is the term that's commonly used for these compounds that go up into the atmosphere and create a blanket around the Earth. They're often thought of as heat-trapping gases. Heat radiation comes in from the sun in addition to light radiation, and then normally some of it would escape back up through the atmosphere. If all of it escaped back up through the atmosphere, it would be as cold as space is on the planet. So we want some of that gas there. Unfortunately, since the beginning of the Industrial Revolution, with the burning of fossil fuels, we've seen an increase in these gases, and that increase has resulted in less of this radiation being able to diffuse off the planet, warming the planet more than we're normally used to.
The gases trap heat, just like glass in a greenhouse. This is not entirely new. There have always been small but significant amounts of carbon dioxide in our air. After all, we breathe it out every minute of the day. Plants then use it to carry out photosynthesis. They make food from the sun and burn oxygen as a waste product, which we, in turn, need to live. Normally, the system is well balanced. Most scientists are now convinced that something is going wrong. The evidence, says Jeff Jenkins of the UK's Meteorological Office, comes from careful observation of the weather.
In order to measure changes in climate, what we do is to take in data from all over the world. All the Met Offices, the weather stations around the world, both on the land and at sea, are collected together, and then we average those to look at how annual average temperatures at the surface of the Earth vary from one year to the next. So we're talking about many thousands of observations during the course of a year being put into this climate record to show us the trends over the last 100 years or so.
But it's not just conditions on land and in the atmosphere that climatologists have to worry about. What happens at sea is just as important. 2/3 of the planet are covered by water, and this stores heat far more efficiently than on the land. Scientists call this a thermal sink, mopping up excess temperature rise and keeping us relatively cool. Ocean currents also play a vital role in regulating the weather. What climate change will do to these massive movements of water, says Jeff Jenkins, is very unclear.
The currents are there in order to distribute heat from the equator to the poles. The whole reason we have climate, in fact the whole reason we have weather, is to redistribute heat from the equator where there's too much of it to the poles where there isn't enough. And about half that work is done by very large ocean currents. We know that ocean currents are very important. We know, for example, that one particular current in the North Atlantic, called the Gulf Stream, brings warm water from the Gulf of Mexico to Western Europe, Northwest Europe, and makes us in Northwest Europe very much warmer than we deserve to be at this latitude. We know in the past that for natural reasons there have been changes in the Gulf Stream. The Gulf Stream has effectively switched off. So the potential is there for the Gulf Stream to switch off again, and that would plunge a lot of the northern hemisphere into a much cooler climate.
That is only hypothesis A. Hypothesis B is the exact reverse, which is that if you warm up the Earth, you release methane from underneath the tundra in Siberia and Canada. Methane is a very, very much more powerful greenhouse gas than carbon dioxide. Then there is the methane hydrates, which is little crystals of methane which are frozen underneath the sea. And if the sea warms, then you will find a sudden warming. And that's happened too in the past. It happened catastrophically about 55 million years ago, when suddenly the Earth warmed up very, very sharply. So you can look at both these hypotheses, one being kind of negative feedback, one being a positive feedback, the first being called reversion to glacial conditions, and the other one being called runaway greenhouse. And no one knows which is likely to happen. Both could happen relatively quickly.
So it's going to get very hot, or very cold, or it might even stay the same. No one is really sure, and that's the kind of scientific speculation that politicians hate. How can they take any decisions when nobody knows whether hypothesis A or hypothesis B, or C, D or E is the right one? Nevertheless, some action has already been taken. Bob Watson.
There is research being done throughout the world to try and understand climate change. There is a group of scientists called the Intergovernmental Panel on Climate Change to try and assess all of this scientific knowledge to provide advice to policymakers in government and in industry.
Now that one sounds terribly straightforward. In reality, this is a political minefield, isn't it?
Yes, it's a minefield because energy, which is absolutely essential for economic growth, is absolutely critical. And hence what we're talking about is potentially changing some of the energy policies around the world and some of the energy technologies around the world.
So what's actually been agreed?
In 1997 there was a meeting in Kyoto, Japan, where the industrialized countries agreed to reduce their greenhouse gas emissions. Now since then there has been a question of will the countries in the world legally ratify the European Union, Japan, New Zealand have already ratified the Kyoto Protocol. The Russian Federation have stated they will ratify it, but the United States has said categorically it will not ratify the Kyoto Protocol.
Dare I ask you why you think that is?
First, they believe there is still scientific uncertainty. Yes, there is still some scientific uncertainty, but the very large majority of the world's climate scientists do believe that the climate is changing and there will be adverse consequences. And indeed, often uncertainty can be the reason for action rather than the reason for inaction. Secondly, they say it will be very expensive. This view is somewhat different from the view of the Intergovernmental Panel on Climate Change, where we did assess the costs of complying with the Kyoto Protocol for most countries in the world, and our view was we tended to have cost estimates much lower than what the US government believes. The third comment by the United States government is it cannot be an effective protocol to safeguard the Earth's climate system unless all countries in the world are involved, not just the industrialized countries.
Now, there's a complicating factor here, isn't there? And that we're not just talking about cutting emissions, we're also talking about other strategies that countries can follow to try and mitigate the amount of carbon in the atmosphere, and ultimately things like carbon trading.
The cost of reducing carbon emissions in, let's say, Europe and the United States is much greater per tonne of carbon than the cost of reducing emissions in many other developing countries. The reason is their energy systems are not as sophisticated and not as efficient as the systems in Europe and North America. And so the cost of reductions are cheaper in developing countries. Hence, given that the atmosphere, given that the climate doesn't care whether the emissions come from the US, Europe, Russia, or a developing country, it will be most cost effective to reduce some of our emissions in developing countries. We can trade carbon emissions as credit, very much like we trade rice, wheat, or any other commodity. So the idea is, let's protect the climate system in the most cost-effective way. And if it's cheaper to reduce emissions in China than it is, let's say, in Europe, then let's at least reduce some of those emissions in China. And China, or the developing country, whichever it is, will also get more modern technologies that are not only climate friendly, but potentially also cleaner with respect to local and regional air pollution as well.
So far, ambitious schemes like carbon trading are largely theoretical. But if it ever happens, then countries with large amounts of forests may benefit. Plants absorb carbon dioxide during photosynthesis. If we preserve or even expand our forests, we might be able to control carbon emissions the natural way.
The largest source of carbon dioxide in the tropics is tropical deforestation. And hence the other approach is to try and work with developing countries who have rich biodiverse forests. If they could slow down their rates of tropical deforestation, it would also slow down the rate we put carbon dioxide in the atmosphere. So managing our forested systems is also a key component of the climate issue.
You might think that forests would thrive in a warmer world. There'd be more carbon dioxide, which would promote photosynthesis, and the higher temperature would encourage growth. But no one is completely sure that this will happen. Climate change could be damaging to forest ecosystems, and evidence that it is affecting the world's natural systems is mounting. The tropical cloud forests of Costa Rica in Central America are rightly regarded as one of the country's greatest assets. Covering the central mountains, they help regulate the weather and provide a home for many plants and animals. At the Monteverde forest, I met up with Richard Laval, a biologist who has spent nearly all his professional life studying this unique ecosystem.
Well, first of all, global warming is accentuated on steep mountain slopes. The effect is greater, and one of the biggest changes is that the average night temperature has risen 2 degrees Celsius over the last 20 years. It is quite a lot, yeah, and that can mean a lot to animals, especially nocturnal animals.
So are you seeing the effect of this temperature rise on the way the animals behave, on their distribution?
On their distribution. Maybe there are behavioral changes, but we're probably not well enough focused to see those. But on the distribution, what we're seeing is the continuous arrival of species which formerly occurred only at lower elevations.
So everything's moving up, basically, to try and escape the higher temperature.
Right. And the effect of this is packing more species in the same area. And this creates an unstable situation in the long run, probably will lead to the loss of some species, particularly those species that require a high elevation forest. If they get pushed up and up and up, there's no place for them to go, they'll simply become extinct.
And are we actually seeing any decline in numbers, any measurable decline in numbers of certain species?
Locally, yeah. Populations that are not very mobile, like frogs, toads, we've lost a lot of those.
You say lost, gone completely.
40% of all the frogs and toads here are gone completely. And that's a high percentage. There were a lot of species here.
Are there any of those out-and-out extinctions?
The case of the golden toad appears to be an out-and-out extinction.
And the golden toad was this spectacular-looking sort of orange, yellow toad.
Brilliant orange toad. The males and the females are black, covered with bright red spots. So they were really spectacular.
Sensible use can guarantee the long-term survival of forests. And in theory, all those trees may help protect us from rising levels of CO2. Forests are remarkably resilient if managed carefully, but other ecosystems are far more fragile. Global warming may destroy them before we've even had a chance to put in any protection measures. Indeed, for some natural systems, it may already be too late. Returning from Costa Rica, many American travelers pass through Miami. Just a short drive from the airport is one of the most breathtaking and most vulnerable of all tropical ecosystems. To see it, all you need to do is to strap on some basic equipment. One of the reasons why people come to the Florida Keys, which is this string of islands that drop down from Miami just off the coast of Florida, like a little string of pearls, is for the diving and the coral reefs. And some people are saying that if they're going to want to see them, they're going to have to hurry because coral reefs are diminishing in size. And some people say that coral may not be with us for very much longer. So I'm taking this opportunity to put a mask on my face and a snorkel in one more. And I've got a couple of flippers on here. And I'm going to investigate this clear water and see what we can see. Freezing! Coral under there is absolutely fantastic. Dozens and dozens of beautiful iridescent fish and stunning, stunning coral. And it's hard to believe that this may not be here in 50 years' time. So what I'm going to do is now go off and meet one of the scientists who's studying what's happening here. Now they call Florida the Sunshine State, and certainly today we've got a fantastic clear day. There's almost no wind, and we've got a beautiful lagoon in front of us here. And I'm with Mark Chapone of the University of North Carolina, and we're here because we're going to talk about what we're actually standing on, which is coral. Now you better, first of all, Mark, explain to us what coral is, because a lot of people listening will never have seen it.
Corals are animals, and they're unique in the sense that they form a symbiotic relationship, a unique relationship with microscopic algae that live within the tissues of the coral animals.
It's almost living together, helping out each other, kind of cooperative living arrangement.
That's exactly what it is. The microscopic algae provide the coral animals, supplement their nutrition, also provide them with oxygen via photosynthesis. The coral animal in turn provides the algae with carbon dioxide and waste products that the algae uses for nutrition.
You've said that this is actually a living organism, and yet if we bend down here and I pick up some of this, this is what you get if you leave coral long enough, isn't it? This is what we're standing on, these rocks here.
Basically, the animal leaves behind a calcareous or a calcium carbonate. Think of that as being something like chalk that you would use on a chalkboard. Leaves behind the skeleton. The difference between what we're standing on and what you see underwater living reef is that there's a very thin veneer of living coral tissue as well as other organisms, such as things that form this thin veneer over this calcium carbonate or limestone base.
What are the main things that coral needs to survive?
Warm water, relatively clear. very low concentrations of oxygen, which further necessitates the need for this symbiotic relationship with algae.
Now, anyone who's ever seen a picture of a coral reef will just be amazed at the diversity of wildlife that's there. There are dozens and dozens of fish, all sorts of crustaceans, other animals. Why are they so attractive to other species?
The structure itself plays a critical role because it provides habitat for things like fishes. There's habitat for spiny lobster, different mollusks, several different other crustaceans. People refer to reefs as basically cities under the sea.
Now, as we know, the climate is changing. We are seeing a rise in temperatures generally. That is unstoppable to a degree now, and we could certainly mitigate it in the long term, but we know it's going to happen over the next 100 years or so. What effect is that going to have on coral?
We've had severe coral decline in the past couple of decades. The incidence and severity of coral bleaching, which is when the corals basically expel their symbiotic algae, and it's usually not a good thing. Corals won't survive such water episodes, and there's a real fear of climate change that if we have a period of increasing temperatures, that sea level will rise. And the problem is that over geologic time this has happened, but it takes thousands of years for it to occur. The problem with what we've seen in the past several decades is that sea level is rising much faster than it has in the past. And so for the ability for corals to maintain growth at keeps pace with that rising sea level is cause for concern. If sea level rises too fast and corals can't keep up, they will eventually become drowned or deeply submerged reefs that won't keep pace.
Do you think more should be done? Are you really concerned that this is a real threat?
Well, the magnitude and the scale of global climate change, I think people have a very difficult time getting their hands on exactly what you can do on a local level. And I think the strategy that's been adopted here is to think globally but act locally. And so they've tried to mitigate some of the effects of pollution.
You say that, but I mean there are dozens and dozens of huge cars traipsing up and down US 1 just a couple of kilometers from here.
That's exactly right. Well, South Florida in general has not adopted the mentality of mass transit by any stretch of the imagination. You basically can't get anywhere without having an automobile. People have to be willing to make the changes themselves unless it's effective. And until it's economically viable, until it is logistically feasible, i.e. you're not going to use your car, how are you going to get from A to B? Until those things are economical and easy to use,
can you really see Floridians turning off their
Well, it hasn't happened yet, and my 2 cents on that issue is that until you hit people in the pocketbook and the wallet, things will certainly not change.
Rich Westerners use far more energy than people in the poor South. They burn petrol in their cars and use huge amounts of energy produced by coal and oil-fired power stations. The average American consumes over 500 times more energy resources in their lifetime than a typical African villager. There are moves afoot to conserve energy and use less polluting power sources like wind farms or solar collectors. But so far, these are only having a minimal effect on gas emissions. This is especially galling for people in poorer countries, since they are far more likely to suffer the consequences of global warming than their well-fed, well-protected Western counterparts. Dr. Tawaldi Eziabir is Minister for the Environment in Ethiopia.
There is evidence that climate has changed in Ethiopia. Most of the people in Ethiopia live in islands. Islands were malaria-free in the past. You had to go quite low down in altitude before you encountered malaria. Now malaria has been creeping up, and the claim is that in the last 20 years or so, the malaria zone has moved up about 200 meters. The same is true of tsetse flies that bite domestic animals and cause animal sleeping sickness. A similar rise in altitude is implicated. The evidence of the rise in altitude in malaria and tsetse flies definitely indicates climate change, and the land degradation will have been exaggerated by the climate change.
Shifting patterns of disease may just be one consequence of changing weather patterns, or farmers may also have to put up with prolonged droughts or changing patterns of soil erosion. Because no one knows for sure what will happen, scientists are urging caution. Far better, they say, to take action now than to gamble on an uncertain future. But not everyone agrees that there really is a problem.
Had it dawned on you that 700,000 of the last 700,000 years, on average, the periods which we've not been in ice have been about 10,000 years. In other words, during the whole of 700,000 years, the little periods that we've not been under an ice age have been about 10,000 years. What's the length of our current period of last 10,000 years? Statistically, we are due for an war. On all the evidence of the last 700,000 years, let me ask you a serious question. Is that the moment at which to start withdrawing something you think of war?
Geographer Philip Stott has long been a thorn in the side of the climate change lobby. We can't be sure what might happen if the climate changes, he says. And what's more, the process is entirely natural. The campaign to limit carbon emissions is inspired not by good science, but by global envy.
Carbon dioxide, we must remember, was selected politically as a legitimising science to control the car, hit America, you name it, control growth, etc. The whole idea of global warming is a political construct. And I like to make a clear distinction between global warming and climate change. Climate change, we know so little about. It's always happening from every second to every minute, right the way through today. It's always happening. Global warming is a political construct. Climate change is the reality of the complexity of life, about which, if you ask me, do we really know much? I would say very little.
Such complacency, argues Laura Hansen, is misguided. Everybody on the planet should be taking this seriously.
Individuals can do a lot to impact what happens with our Earth's atmosphere. The reason that we have greenhouse gases in our atmosphere now is because of the actions of people. And you can take actions independently to reduce your greenhouse gas emissions. You can have greater energy efficiency in your home as well as in your method of transport. Personal action is a big step in this.
We do need to be taking much more action now, and some countries are beginning to do so. But they all involve changes in the way people regard the climate, changes in the way in which we produce things, changes in the way we conduct our lives, and these are things that can't happen very quickly.
The reason that the Earth is warming is because throughout the world we are burning coal, oil and gas and putting carbon dioxide into the atmosphere. And in the tropics we're cutting down the trees, which also puts carbon dioxide into the atmosphere. Hence, if we want to try and stabilise or control our climate, we have to deal with energy practices and land use practices throughout the world.
Next week, we return to the future of forests to find out if the way we manage land may be turning the world into one vast desert.
Find people describing trees that existed in their immediate vicinity when they were younger no longer exist there. Deforestation, burning with fire for agricultural production. It's happening.
What is meant by desertification? I would like it to mean turning into a desert. And it has happened. In the Neolithic, the Sahara was covered with trees. There were people wandering around with cattle. And then it turned into a desert. That was desertification.
The actual rate of deforestation has been estimated to be at over 14.6 million hectares each year. But what does that mean? That's a huge figure. Well, it actually equates to an area the size of Nepal. And that equates to losing 37 football pitches of forests every minute of every day.
Mankind has always sought to change the natural world. The very first farmers began a process of taming the wilderness that has not stopped to this day. But early land use was on a small scale. All that changed with the rise of industry. Forests were felled en masse. Farming expanded to occupy almost every available corner of land. The industrialized powers then colonized the rest of the world, and these dramatic changes became global. Today, land use is changing faster than ever before. The rush to transform the landscape has had many unforeseen consequences. As trees were removed, soil erosion took place. Intensive farming degraded land. The Great Dust Bowl, for instance, that hit America's Midwest in the 1930s, was a direct result of inappropriate farming methods. By the late 1960s, another phenomenon was being noticed. The world's deserts were expanding. The process is still going on, but no one is sure whether this is permanent or how fast it's happening. The only thing we do know is that when productive land turns to desert, its ability to sustain life decreases dramatically. How we manage and use the land is at the heart of the problem. Is intensive agriculture and forest destruction turning the world into a barren wasteland? And if so, should we be taking action? Tiwaldi Egziobir, Ethiopia's Minister for the Environment, believes we should. Patterns of rainfall are changing, he says, and that spells trouble.
By definition, a drought is only rainfall that is below average. So this is nothing new, but the impacts are